Hi, in this series, we'll continue the H2 Mathematics 2022 Paper 2. So, for question 7, it is still on probability and random sampling. And so, it's really more of a standard answer to this type of questions. So, let's just see. We are supposed to explain whether the 53 employees form a population or sample. But we know that in total there is 75 employees, and so this 53 is just a subset. And thus, this means that the surveyed people is forming a sample only, because a population is the total number of people. For part 2, now it's just asking you how do you want to carry out the investigation, and the most common one, but again you should follow what your teachers usually give you as the suggested answer. But for me, I'll just say that they are randomly chosen so they can prevent any biasness, and that the sample size must be large enough so that the average views will be a better representation of the views of the population by the central limit theorem. So you first need a random sample, and then you just need it to be big enough. That's all that's how you should get the 2 marks. For part C now, they just ask you to count. So they ask you to find the number of ways to form 8 team leaders, and each of the departments have 1. But then the thing is, the condition is that the team leaders from the administration will always be more than any other. So we start off by giving 1 to everyone first, and then we just give the rest all to A. So there's 5 A's, 1 P, 1 M, and 1 S. So you just do it, and then you get 5, 1, 1, 2. So 7 choose 5 times 6 choose 1 times 4 choose 1 times 3 choose 1. In case 2 now, you have 1, 1, 1, 1, but you give 1 more to either of these. So it's 4, 2, 1, 1, 4, 1, 2, 1, 4, 1, 1, 2. And again, you can do a simple calculation to see that it's 12,600. And for part 3 now, it's 3, 2, 2, 1, 3, 2, 1, 2, 3, 1, 2, 2. And you get 19,530. But now, you can't have this have 2, because once this is 2, then it's either 2, 2, 2, 2, or 2, 1, 1, 3. But that's not 2, 1, 2, 2, 1, 3. But that's not possible, because now you must always ensure that A has more than the rest. So this will be where it stops in the process of writing down all the cases. And because these are all exhaustive and exclusive, we can just add them up by the addition principle, and the total number of ways will be 3, 3, 6, 4, 2. I hope this is clear, and now we'll move on to the next question. For question 8 is testing your idea of the normal distribution. So first they give you the x normal and the y normal distribution, and they're supposed to write the distribution for ax minus by. Well, taking 2 normals and multiplying a scalar will still be normal, and taking any linear combination will also be normal. And so ax minus by will continue being normal, with the mean now is just AP minus BS. So the mean is just the expectation of this, and by linearity of expectation is just this, which gives you this answer. As for variance, you know that for variance you must square the coefficient, and variance, even if this is minus, the square of minus b is still plus, so it's just plus b square. So everything is just addition in variance. So this will be the answer. As for part B now, they just ask you sketch the distribution given this more information. So you know that the probability of being larger than 8 is the same as the probability of being less than 4. Well, you can standardize it to see that being larger than 8 minus mu over 2 is the same as being less than 4 minus mu over 2. So you can imagine here is like 8, here is like 4. When you standardize them, you shift it to like a 0 point. So this is like 8 plus mu over 2. Then this is 4 minus mu over 2. But because this is symmetrical, this value is the negative of this value. So 8 minus mu over 2 is the minus of this. And you solve for mu to get 6. Then you can draw the graph with the middle being 6. And we want to, on the sketch, we can represent p larger than 10. So on the same sketch, you're supposed to draw it here. But I'll just redraw it and then I'll just shade 10 here. And to find its value, you just need to standardize. You see the value that it gets, and then you can use the GC. Or you can just use GC straight away with the standard deviation 2 and mu 6 to get the answer. For the next part, we are supposed to find the probability that W is less than 2. And so W follows binomial 8p. So the expectation, which is the mean, is 8p. And the variance is np 1 minus p. So it's 8p 1 minus p. But we know that the mean is 1.2 times the variance. So 8p is 1.2 times this thing. And we can now solve for p, which is 1 over 6. So then we plug in our 1 over 6 here. W less than 2 means W is either 0 or 1, because binomial is a discrete random distribution. So it's either 0 or 1. To calculate 0 is just 5 over 6 to the power 8. Then to calculate 1 is 8 choose 1 times 5 over 6 to the power 7 times 1 over 6. So then you get 0.605 3SF. The next question again will be testing our idea of modeling probability questions. And so now we are given a game and it starts from S. It can now move to L or R equally likely, so this is half-half. So you can imagine this game as your probability tree so that you don't get confused. And every junction, now you have either same probability to move P left times P, move left by a probability of P, or move right by a probability of 1 minus P. So you eventually reach one of these endpoints, and we're supposed to show that the probability that it reaches B is 2p cubed q plus half p4. Well, how do we do that? So we must split it in two cases, because you can either go left first or you go right first. So if you go left first, then you still have an option of going right at 4 different points. And so you first times half for the probability of going left, then you choose 1 to choose when you go right, then it's p cubed times q. As for the next part, you're right first. If you go right already, then your only way is you go left all the way. So then you only get p to the power 4. And then you get the result that you want. So the next thing is that we're supposed to simplify a fraction, find a simplified fraction for the probability that John and Kate's counters follow the exact same route. So this means that the probability both same, but we already know what is given, that they both arrive at counter B. So it must be given this. Like I said, we always want to write this probability first, then it looks clear. Then we just use the formula, probability both same and reach B over both reach B. Well, both reach B is obvious, because we just need to square what our result is over here. As for both uses the same result and reach B, well, first we need to again split into the two cases, because there are different probabilities. So let's say John takes one route to B. So he took one route. So that's half times p cubed q. So whatever route he took, that's the specific route he must use that way to go. Then B, Kate must again take the same route. So he got this. And then because there's 4 different routes that you can choose from, is times 4. So I hope this part is clear. But it is the same concept as the next part that we're doing. So if you understand the next part, you'll understand how to get this as well. So let's say now you go right. So it's half times p to the power of 4. Then John must again go right, because that's the only way to have the same route. So it's again half times p to the power of 4. So in the left case, we have 4 ways to do it. Four different ways. You go left already, then you either go like that. So this is John choosing first. Then Kate must again use the same way, so it's the same probability. But you have now 4 different choices. So then you get this fraction, simplify out, you should get this result in the end. If you have any questions, please feel free to leave it in the comments below. And now, the question asks you to find what is P. Because we now know that the probability of going to B is the same as going to C. So we need to find the probability it arrives at C. So you go left first, half. Then you 4 choose 2 times P squared Q squared plus half. 4 choose 1 times P cube Q. And you get this. So we know this is the same as this. Since P doesn't give 0, you can cancel all these P squareds. And you get this following. But we know Q is actually 1 minus P. So you just sub it in, get a quadratic, and solve the quadratic. And you get P equals to 1.689 or P equals to 0.710. But because probability cannot be greater than 1, this part has to be rejected, and so this is our answer. So this comes to the end of this video. I hope you have enjoyed it, and feel free to share it with your friends to promote learning. If you have any questions, please leave it down below and I'll answer it. I'll see you again. Bye.